Today we explore the hidden complexities in our industrial world. We're talking about something seemingly simple, the industrial safety switch. Imagine a busy factory. Machines hum, robots move. What happens when a worker needs to hit that e-stop or a safety gate opens? For decades, the safety relay has been the guardian, ready to cut power. And the common question, can we wire multiple e-stops and gate interlocks in series to one safety relay input? The quick answer is often yes. It saves wiring, it simplifies things. But what if this seemingly simple solution hides a critical vulnerability? A flaw that could undermine the very safety you're trying to achieve? Our topic today isn't just about wiring. It's about diagnostic integrity, detecting invisible failures. When you wire multiple traditional mechanical safety switches in series, you're creating a single, unbroken chain. The safety relay uses two independent channels for redundancy. If either wire opens, someone presses an e-stop or opens a gate, the relay trips. Machine stops. Crisis averted. Sounds perfect, right? Here's the secret: fault masking. What if one link in that chain fails silently? What if, say, one of the two contacts inside an e-stop button welds shut? A rare but possible event. A fault now exists, but because it's in series, it might go unnoticed. If someone then opens a different gate or presses a different e-stop, the machine will still stop. You get a safe state. But the welded contact, the hidden failure, it remains undetected. It's masked. You have a dangerous single point of failure lurking, waiting. This isn't just theory. In safety standards like ISO 13849, this directly impacts your performance level. If you can't detect significant faults, your system's actual safety is lower than assumed. So what's the solution? Do we abandon series wiring? Not necessarily. Innovation steps in. The future of safety lies in diagnostic coverage, making the invisible visible. Firstly, electronic safety switches with OSSD outputs. These aren't just simple contacts. They're intelligent. They pulse signals, self-monitor, and detect internal faults, shorts, or open wires. Wiring these in series maintains high diagnostic coverage because they signal internal failures before they're needed for a stop. Secondly, for complex systems, we have safety PLCs. Instead of one series chain, each e-stop or gate switch gets its own dedicated input. This eliminates fault masking. If an e-stop is pressed, you know exactly which one. If a contact welds, the PLC can often detect that specific anomaly. This not only makes your system safer, but also drastically reduces troubleshooting time. Safety isn't just about implementing a device, it's about understanding reliability and fault detection. While series wiring offers simplicity, true safety lies in a system's ability to diagnose its own health, exposing weaknesses before they cause an incident. As we automate, our responsibility to protect human life must evolve. It must embrace intelligent design, proactive diagnostics, and a deep understanding of how our safety circuits truly behave. So next time you see an e-stop, remember it's not just a switch. It's a critical component in a vital system. And how it's connected can be the difference between a simply stopped machine and a truly safe environment that silently watches over its own integrity. Automation Distribution can help you assess your current application and introduce you to the latest in automation safety products. Contact us at 1-888-600-3080 or visit us online automationdistribution.com.